All right, let's talk about an invisible force that's literally all around us. It's in your glass of water, it's in the deep end of the pool, and it's definitely in the ocean. It's called liquid pressure. And trust me, by the end of this, you'll see it in a whole new way. You know that feeling, right? When you dive down deep in a pool and your ears start to feel weird? That strange, kind of uncomfortable pressure building up? So, what's actually causing that? Let's dive in and find out. It really all comes down to the sheer weight of all that water. We're calling this whole idea that sinking feeling. And nope, we're not talking about exam pressure here. This is a real physical force. Just try to imagine the weight of all the water above you, pushing in from every single direction. It's totally invisible, but with a super simple experiment, we can make it perfectly visible. So, how do we actually see this in action? Well, we're going to do something called the leaky bottle experiment. It's such a brilliant and simple way to make this invisible force, well, tangible. And when I say simple, I really mean it. All you need is an old plastic bottle, some tape, a pin, water, and a sink. That's it. You probably have everything you need to try this yourself right now. The setup is super straightforward. First, you just carefully make 3 holes at different heights on the side of the bottle. Then you cover them all up with 1 piece of tape. Finally, fill that bottle all the way to the top, and now we're ready for the fun part. Okay, so we've got our bottle. It's filled with water. Holes are all taped up. Before we see what happens, take a guess. When we rip off that tape, is the water going to stream out of each hole in the exact same way? And there it is. Just look at that difference. The water from the top hole kind of just trickles out, right? But the stream from the bottom hole, wow, it shoots out with some real force. There's a huge difference in power. So that brings us to the big question, why? Why does that happen? Well, that takes us to our next section, the science of squish. Yeah, why does that bottom stream have so much more oomph? What is the actual science behind what we just saw? The secret ingredient here is something called water pressure. And really, it's the force created by the weight of the water above a certain point. Everything, and I mean everything, comes down to that one word, weight. This picture just lays it all out perfectly. Think about the top hole. There's not a lot of water sitting on top of it, so less water means less weight, which means less pressure. But then you look at the bottom hole. It has the entire column of water above it pushing down, so more water, more weight, and way more pressure. And that is why that stream is so powerful. You know, there's another cool little detail here. Did you notice that as the water level in the bottle drops, all the jets start to get weaker? It makes total sense, right? Because there's literally less water, which means less weight above each hole to push the streams out. It's a direct, visible relationship. Okay, so a leaky bottle is a neat trick, but who cares, right? Does this stuff actually matter in the real world? Oh, absolutely. Let's take a look at where this pressure plays a huge role. So who's got to be an expert on this stuff? Well, deep sea divers, for one. They have to literally train their bodies to handle the insane, crushing force of the ocean depths. And of course, submarine engineers. Their entire job is to figure out how to build something that can survive being squeezed from all sides by thousands of tons of water. And when we say squeezed, the scale is just mind-boggling. I love this analogy. At the bottom of the ocean, the pressure is like having an elephant stand on your finger. Just try to imagine that for a second. That is a staggering amount of force. And that right there, that's why submarines have to be these absolute marvels of engineering. They're built from unbelievably strong materials just to keep them from being crushed like an empty soda can. But here's the really wild part. This whole idea doesn't stop with water. The air around you, right now, it has weight too. And air pressure works the exact same way. You are constantly experiencing the weight of the entire atmosphere. That's miles and miles of air pressing down on you. So I'll leave you with this little brain teaser to think about. If air has weight, just like water, and it's pressing on you from every direction, just what is the total weight of the atmosphere your body is holding up right now? The answer is pretty astounding, and it's an incredible thing to think about.